Everything I learned in Calculus 1, also known as Math 137. All right, time for pre-calc review. You should already know this, and if you don't, why are you taking this course? A function assigns each x to exactly one y. The domain is where the function is defined. The range is the set of numbers the function attains, and the roots of a function are where the function attains exactly 0. A function is even if f of negative x equals f of x. A function is odd if f of negative x equals negative f of x. A polynomial is a function in the form of p of x equals an times x to the n plus an minus 1 times x to the n minus 1 all the way to a1 times x plus a0, where every single a is an element of the reals and every single n is an element of the naturals. A power function has the form f of x equals x to the a, where a is an element of the reals. For example, the square root of x, 1 over x, which is the same as x to the power of negative 1, and x squared plus 1. A rational function is a polynomial divided by another polynomial. An exponential function has the form f of x equals a to the x, where a is an element of the reals and a is greater than 0, because if a is less than 0, then we get imaginary numbers, and this ain't algebra. The natural exponential function uses the magic number e as a, and if you don't know what e is, look it up or you're screwed. A logarithm function has the form f of x equals log base a of x, where a is greater than 0 and a is not equal to 1, because imaginary numbers again. The natural logarithm function, again, replaces a with e, except this time we write it as ln of x. Trig functions are related to right-angled triangles. Sine of x equals opposite over hypotenuse, and cos of x equals adjacent over hypotenuse. Tan of x equals sine of x over cos of x, which equals opposite over hypotenuse over adjacent over hypotenuse, which reduces to opposite over adjacent. You can remember these with SOHCAHTOA or forget them and have a hard time in calculus. Piecewise functions are split up into different pieces, where each piece is another function. Composite functions are where you apply a function to the output of another function. For example, if f of x equals x plus 1 and g of x equals x squared, f of g of x equals x squared plus 1, and g of f of x equals x plus 1 squared. Inverse functions are functions that take the output of one function and return its input. So f inverse of f of x is just x. These only exist where there's exactly one y value for each x value. If there's more than one, then you have to restrict the domain because the square root of x squared could be plus or minus x. Now, on to polynomial long division. If we know one root of a polynomial, then we can do long division to factor the function. For example, if we know that the root of x to the 3 plus 10x squared plus 13x minus 24 is 1, then we can use the corresponding factor x minus 1 to divide this polynomial to factor it. So we're going to start with x to the 3 divided by x, which gives us x squared. Then we're going to take this x squared and we're going to multiply it by x minus 1 to get a new line, which gives us x to the 3 minus x squared. Then we're going to take this line and subtract this line from the previous line, which is x to the 3 plus 10x squared plus 13x minus 24, and get the next line in the division. So this would give us x to the 3 minus x to the 3, which is 0. And then we get 10x squared minus x squared, which gives us 11x squared. And then we're going to carry over the two remaining terms to give us 11x squared plus 13x minus 24. And then we repeat. So we do 11x squared divided by x, which gives us 11x. And then we're going to multiply 11x by x minus 1, which gives us 11x squared minus 11x. And then we're going to subtract that equation from the previous. So 11x squared minus 11x squared is 0, and 13x minus 11x gives us 24x. And then we're going to carry over the remaining negative 24 to create our new line. And we're going to repeat this process again. So 24x divided by x is just 24. Then we're going to take 24 and multiply it by x minus 1, which gives us 24x minus 24. We're going to subtract this line from the previous. So 24x minus 24x is 0, and negative 24 minus 24 is 0. So no remainders, which gives us our new factored equation, x minus 1 times x squared plus 11x plus 24. Now, absolute values and inequalities. Absolute value is often seen as a function that just removes the negative sign from a number, which is pretty much exactly what it does. But in calculus, we define it more accurately as the absolute value of x as a piecewise function. It's just x if x is greater than or equal to 0, and it is negative x if x is less than 0. And some basic properties of this is that the absolute value of x times y is just equal to the absolute value of x times the absolute value of y. And the absolute value of negative x is equal to the absolute value of x. And now for inequalities, if x is less than y, then x plus z is less than y plus z. If x is less than y and y is less than z, then x is less than z. If x is less than y and if c is greater than 0, then c times x is less than c times y. If the other way around, if c is less than 0, then c times x is greater than c times y. Back to absolute values, the negative of the absolute value of x is going to be less than or equal to x, which is less than or equal to the absolute value of x. The absolute value of x, if it's less than some number delta, that implies that the negative of delta is going to be less than x, which is going to be less than delta. And if the absolute value of x is greater than this number delta, that implies that x is greater than delta or x is less than delta.